Hey y'all, in this video, I'm going to demo how to add real-time vector search capabilities to an application using Modus, which is Hypermode's new serverless framework. Now, before we jump into things, I want to mention that the GitHub repo with all the final code from this video is going to be linked in the description below. I'm also going to link a guide that goes into a little bit more detail on the same topics covered in this video, as well as the Modus documentation. So if you prefer written content, go ahead and visit those links. Now, before we get coding, I want to briefly mention what exactly Modus is. So Modus is an open source serverless framework powered by WebAssembly. It is built for creating functions and APIs. So you write your logic in either Go or assembly script, and Modus makes it easy to integrate AI models, data, and external services. So now let's jump into actually building with Modus. Now the first thing we need to do is make sure we have Node 22 or higher installed. And then we need to install the Modus CLI, and we can do that by running this command in our terminal. So this command installs the CLI globally so we can access it from any directory. And now we can create a new Modus project by running Modus new in our terminal like this. And this is going to give us a few prompts. So first, it's going to ask us to choose our programming language. We have the option of either Go or assembly script. In this example, I'm going to use assembly script. Next, we're going to be prompted to name our project. So let's go ahead and name it. Okay, so now our Modus project has been created and we can open this in our text editor. Now, notice we have this modus.json file at the root of our project. This is the manifest for the application. So it's where we define connections to external services and configure the application. So this is where we define and configure our project's resources, including models, hosts, and collections. So first, let's add our AI model. And in order to perform vector searches, we need an AI model that generates vector embeddings from text data. So we'll use a model from Hugging Face, and we can add it like this. So here, source model specifies the AI model that we're going to use. Provider indicates the source of the model, so here it's Hugging Face. And connection specifies that the model, in this case, is going to be hosted on Hypermode. And just once again, this model will generate the vector embeddings that your search functions will use to return relevant results. And we'll go over that more in just a bit. So next we need to configure our collections, and collections are built-in key value storage systems with support for vector embeddings. This enables natural language search capabilities within your functions. So for this project, we're only going to have one collection called text, and this is for storing the text that we want to search through. So here's how we can configure this collection. Notice this has a search method configured. These settings define how searches will be performed on the collection. So in this case, we connect the collection to the mini-elem-embed function, which generates vector embeddings for the text. This enables similarity-based searches, and we're going to cover how to create this mini-elem-embed function in just a little bit. So now our project manifest is configured, and we can start writing our functions. Our Modus functions are exported from the root of our assembly directory. So let's move into that directory and into the index.ts file, and we can delete everything here for right now. Now, the first thing we want to do is import the following modules and types. Here, collections allows you to interact with the collections for storing and retrieving text and other relevant data. Models is where we access AI models for embedding generation. Specifically, we'll use the embeddings model, which is also imported here. And this allows us to convert text into vector embeddings for similarity-based searches. Next, we need to define the key parameters for interacting with the Modus environment. So we have text collection, which specifies the name of the collection where the text data is stored. Remember, we configured this in our Modus manifest. We have search method, which defines the search method to use, in this case, search method 1, again defined in our manifest. And then embedding model name, which indicates the AI model, which is mini-LM, responsible for generating vector embeddings from the text. And again, this is also defined in our manifest. Now, these values will be used throughout the application to configure how we store, retrieve, and search through text data. So to start, let's add our upsert text function. This function is going to be responsible for inserting or updating text data into our text collection. And it accepts IDs and texts as parameters. So IDs is going to be an array of unique identifiers, And text is going to be an array of texts to correspond to the unique identifier. So in this function, we first check whether the IDs and text arrays are the same length. This prevents a mismatch of data. And then it uses collections.upsert_batch to insert or update text in the text collection. And if the upsert fails, it collects and returns error messages. Otherwise, it returns an array of IDs indicating a successful upsert. So next, we can add our search function. This performs a semantic search on the text collection, and it returns the text entities most similar to the user's search query. So it accepts one parameter, query, which is the search string provided by the user, and it performs a vector-based semantic search using the collections.search method on the text collection with the provided query and specified search method, which, if you remember, is configured in our manifest. This is the mini-lm embed function, which we create in just a second. Next in this function, if the search is successful, it loops through the search results, retrieving the corresponding text for each result from the collection using collections.getText. And the function returns an array of the most relevant text based on the search query. So this function is essential for leveraging Modus's vector search capabilities, allowing you to effectively retrieve text data based on semantic similarity. So now let's finally define that mini-lm embed function that I keep mentioning. This function generates vector embeddings from an array of text strings, and it's crucial for converting text into vector representations that can be used for a semantic search. So this function accepts one parameter, text, which is an array of strings to be embedded. So it retrieves the mini-lm model, and it prepares the input, the array of text, and invokes the model. The model returns embeddings or vectors for the text, which are used in the vector search. And now we've written all three functions that we need for embedding text data and performing vector-based searches. The upsert text function allows you to add or update text entries into our text collection. The search function performs the semantic search based on our user queries, and the mini-lm embed function generates the embeddings necessary for powering the search functionality. So now we can deploy this to Hypermode and start testing our real-time vector search capabilities with our own text data. So let's push these changes up to our GitHub repo, and now we can create and deploy our Hypermode project. So back in our Hypermode dashboard, let's go ahead and click Create New Project, and we're going to have to name it. This will automatically generate a slug based on the name, and then we can click Create. And just like that, a new Hypermode project has been created. Now we need to trigger a deployment. So we can skip this first step because we already created our Modus app. So let's go down to this Initialize Your App with Hypermode section, and we're going to have to link our repo. And then we'll trigger a deployment. First, we'll create this new file. We'll copy and paste this code to create a GitHub action. And then we need to push this up to our GitHub repository. Now, making this commit is going to trigger a deployment. So if we go back to our Hypermode dashboard, you can see a deployment has been queued. And if we wait just a little bit longer, we see that now it has been deployed. But before we can test this out, we need to add some data. So here in this homepage of the dashboard, you can see it shows us our functions, our models, and it shows us our collection, in this case, text. We can click this button and it will give us the option to upsert data using a CSV. Now remember, we also created that upsert text function. So if you'd rather use that to upsert data, you totally could. But in this case, we're just going to upload our CSV with no headers. Okay, so now our data has been uploaded and we can test out our instant vector search functionality. And we can do this in our query tabs. So if we just move to our query tab, we can query our search function, passing in a string of text as our query. And if we click this button, we see that it returns semantically similar results. So that concludes our demo on using Modus to integrate instant vector search capabilities into an application. As I already mentioned, all of this code is linked in the description below, as well as a guide that goes into even more detail about this if you want to learn just a little bit more. As usual, if you have any questions, leave them in the comments below, and thanks for watching. Bye.